3. So it has a bonding capacity of 3. What about chlorine? 1. So chlorine can only make 1 bond, nitrogen can make 3. B says, theoretically, so theoretically means you can explain on paper. There's 2 different types of knowledge. There's empirical knowledge and theoretical knowledge. Empirical is what you see happening in an experiment. So empirical is doing. Theoretical is what's the explanation. Okay? So you can't see an atom. You definitely cannot see an electron. So really, any explanation that you give for this would work, right? So nitrogen makes 3 bonds, chlorine makes 1.
If they ask for, let's say it was boron or something like that, is the bonding capacity that would still be 3?
Yes,
Okay.
for boron.
Because it was
Well, no, because boron only wants a total of 6. It's an exception.
oh, okay. Well, like,
Yep.
okay, carbon then.
Carbon,
Yeah, 4.
yeah.
So we're getting plus or minus.
It's plus or minus if it makes an ion, but it actually shares to make an extra 4 join it. Yeah. So when we're talking about all these nonmetals, bonding capacity means how many bonds do they form. So how many extra electrons are they looking for?
Okay, so carbon on.
Yeah, because it has 4, needs 8. Okay, so here you go. This should help in your explanation. Seems how we were talking about Lewis structures. Good chance the answer has to do with Lewis structures. Does that help? Look at what I drew. Why does nitrogen make 3 bonds? Why does chlorine make 1? Craven? Chlorine is short 1. It only needs 1, and it gets that through a bond. Nitrogen needs 3 more electrons. It gets those by sharing to gain those 3. Yeah. Okay. You don't get to be a critic. Okay, so nitrogen is short 3, so each bond they make gets them 1 more electron. So every bond that you make brings 1 more electron into your valence shell. Okay? Perfect example of octet rule. Nitrogen and chlorine both want 8. So they're going to share what they've got in order to gain those.
So if they're together and 3Cl.
What would it be?
And 3Cl.
So I would need 3 nitrogens and 1 chlorine.
Other way around.
Other way around. That's exactly what would happen. Good. Okay, oxygen, combining capacity of 2. So it's got to make 2 bonds. Oh, I just marked you absent.
Probably slight
Which you could have got at lunch. Okay. Okay. So top right shows a coordinate covalent. It's got one coordinate covalent, two polar covalent. We can't tell which one it is, and it's going to form ionic bonds. This is actually what we get in water. When an acid dissociates, we form these, not H pluses, but we'll get to that when we get to acid. Who makes three?
Sodium. Nitrogen. Phosphorus.
One more.
Phosphorus. Oh wait, I'm
Give me one more.
Oh, it's only AFs.
Rhymes with moron.
Stefan. Got him.
Is an exception to the rule, right? Makes three. Who makes four?
Carbon. Silicon.
Okay, we're going to leave it at that. Okay, so this is going to help you when you do Lewis structures. If you are in a chemical formula and you have 2, 3, and 4, there's a good chance you're in the middle. If you have a higher valency, you are more likely to be the one in the middle. So let's say you've got a compound that contains carbon, nitrogen, and hydrogen. It contains carbon, hydrogen, and nitrogen. Who is most likely the one in the middle? Carbon. The one that makes the more bonds is in the middle. Okay? Sometimes you're going to have chemical formulas. They'll give you the formulas, and it actually lays it out in order for you, which is nice, and sometimes they don't. An example of that would be CH3C H2OH.
That's a big one. Look at that.
Okay? No, not yet. Just watch. Watch, watch, watch. This could also be written as C2H5OH. Okay? This is the same molecule. The first one is a condensed structure. It tells you the order of the atoms. The last one just tells you the number, but it also identifies that you have this group. When we get to carbon-based compounds in grade 12, that's really crucial. This is the stuff that gives you headaches and hangovers.
A. What is it? Alcohol?
The kind, the only kind our body can actually drink. You can't drink any other alcohol. Methanol will make you go blind. Propanol is used as a cleaner. Everything, all alcohols are toxic, just this one is not as toxic. And for some reason, we like to drink it until it gets to that point. So, but this can still kill you. Like, don't kid yourself. This can still kill you. Okay, so this is ethanol. Okay, so pay attention to how it's laid out. The first one is telling you you've got 2 carbons in a row and then an oxygen. The other one doesn't tell you anything other than how many atoms you have, okay? You can copy that down. Yep, if you want. Oxygen, how many valence electrons? You need your yellow periodic table, 6. So we have a total of 8 electrons to place. 8 electrons total. Okay? Who's the central atom? Who's got the highest combining capacity? So you know oxygen is going to have both H's bonded to it. H can't make any more bonds. How many electrons are in each bond? 2. How many did we just use up then? That leaves 4 electrons left. So, subtract the number of bonded electrons from the total of valence. Done. It's 4. It says place the remaining electron pairs around the terminal or outside atoms. How many more does hydrogen need? 0. Done. If there are any left over, put them on the central atom. We've got 4. Put them in pairs. We have none left. If the central atom does not have a full octet, do we have a full octet? Yep, we're done. How many electrons surround oxygen? Total. Total. 8. 2 bonds, 2 lone pairs. 8. How many surround each hydrogen? 2. They're happy. Everybody's got as many electrons as they want. You don't have any left over. You haven't missed putting any in. That's the correct Lewis structure for water. That's something you've done already, right? So now let's do something a little harder. OF2. Two fluorines, yes. How many does fluorine bring? 7. So how many do 2 bring? 14. How many does oxygen bring?
6.
For a total of 20 electrons. So we've got 20 electrons to place. 2 times 7. It's like a potluck. You bring, but everybody shares. Okay. Who's the central atom going to be? Is it going to be fluorine or oxygen? Oxygen, because fluorine could only make 1 bond. Combining capacity that we just did. Which is why we did it. Okay, so use that. It's going to help. Okay, how many electrons did we just use up? 4. So how many do we have left? 16. How many does each fluorine want? Total. Octet rule. It wants 8. How many does each fluorine currently have? 2. So how many more do you have to place on fluorine? 6. 2, 4, 6, 2, 4, 6. How many did we just use up? 12. So how many do we have left? 4. Go to your central atom. 2 and 2. And we're done. Double check. Always double check that you haven't put in too many electrons. So, we had 20 to start with. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 8 electrons. 8 electrons. 8 electrons. You did it. You did it for something that you've never seen. Any questions? I know I'm talking fast.
No, everything perfect.
Okay, want another one?
No, I'm okay.
Yes.
Yes. I'm alright. Thanks for asking. I just want to, ready. I just really want to.
I was ready.
Two. CBr4. CBr4. Eight electrons. Each bromine needs another 6.
Yes.
Do I have 24 electrons? Yes. I do. Each atom is surrounded by 8 electrons. Carbon, bromine. Isn't that cool?
How many is it?
That's some blues, right?
28.
Okay,
Yeah, nice.
here we go. CO2. Oops. CO2. So put your pencils down for a sec. Look at this. How many did I just place?
0, 4.
I have 12 left. Where do you put them next? Around the terminal, the outside ones. So 2, 4, 6. Now it has 8. 2, 4, 6. Now it's got 8. Subtract my 12 and I've got 0. But I've got a problem. Carbon only has 4. If there's any left, put them on the central atom. Next one, if it does not have a full octet, one or more pairs become a double or triple bond. So what happens if you're short on your central atom? Make it into a double bond. So there you go. Now how many would carbon have? 6. Got to do it again.
Again, how do you know if it's not slanted?
I know it's not slanted because I've done it. Probably a lot. Carbon,
We did it slanted by accident or
well, you're not going to anymore.
only
Today's fine. Okay, don't pack up yet. Stop. Wait. Stefan.
I'm not.
Okay.
I'm not.
How many electrons have we used? 2, 4, 6, 8, 10, 12, 14, 16. That's good. How many does each atom have? This oxygen, 2 bonding pairs, 2 lone pairs, 8. Ditto. And then carbon in the middle, 8. Don't skip steps.
I won't, I promise.
Okay.